Hi friends, welcome to the Officer series of ABM. In Officer series, we are covering all the subjects ABM, BFM, ABFM, BRBL. You know it now, by now. Numericals, objective questions, case studies, everything is covered. Watch it fully, share it with your friends, like the video, subscribe to the channel. See, everything is free over here. Subscribe. Just click on that bell icon. And new batches are starting. I'll come to that later at the end. Today's topic is estimation. Yesterday we had done this probability. Very difficult one. Okay? So follow that also, this also. Share it with your friends. Let's start. Choose the desirable properties of an estimator from the following options. Desirable properties of an estimator. Okay, of an estimator. So what is an estimator? This is a chapter of estimation in your book. Module A, estimation. So this estimator means it's a tool or it's a pivot, you can call it. It's used. So it should be what? Unbiased, efficiency, consistency, and all of the above. See, unbiased means what? Any estimator, we do the estimation based on estimator. What is estimation? See, we do some experiment to the sample. Okay? And from here we apply to the whole population. We'll apply this to the population. So the estimator or the parameter which we are using for this sample, doing the estimation, this parameter should be what? Unbiased. Unbiased means what? It shouldn't be biased towards anyone. Okay? Means it should be equal for all. Second, efficiency. It should be, if I use this estimator, no other estimator should be required. Otherwise what happens? This I have used, let's say any estimator. Estimation I have done. Then I'll say, oh, something is missing in this. So I'll have to use some other thing. That should not be the case. Consistency means if I do the experiment with the same estimator n number of times, it must give me consistent results. So which one of these is true? Or all of these are true? So the answer is all of these. Because any estimator should be unbiased, efficient, and consistent. It should give you the same results, similar results. Okay? Read the following statement and choose the correct option. Correct option. Huh? You want the correct option. Statement 1. The central limit theorem states that the distribution of sample means approximates a normal distribution as the sample size gets larger. Statement 2. In central limit theorem, the average of the sample means and standard deviations will be equal to the population mean and the standard deviation. So the average of the sample mean and the standard deviation will be equal to the population mean and the standard deviation. Which is the correct one? What do you think in this? Very important. This case study comes in exam. Almost every exam it is there. Okay? So which is the correct one then? Yeah? Which is the correct one? Think fast. First one is correct. Okay, let's do it one by one. Okay? First one is correct. What do you say? First one is correct. You agree with this? So first one is correct. Got it? First one is right. Okay, because as the sample size increases, okay, as the sample size increases, the distribution will move towards the normal distribution. Okay. So, see this, what does this mean? It means as I go on increasing the sample size, the distribution will move towards normal distribution like this. This is what the meaning of statement 1 is. Now about statement 2. The average of sample means and standard deviation will be equal to the average of population mean and the standard deviation. Is this true? Yeah. Is this true? So that is the basic logic of estimation, or that is the basic logic of the center limit theorem. Okay. So the basic logic of center limit theorem is, as you go on increasing the sample size, the distribution move towards normal. And second point is also true. This is also true. Okay. So the average of sample means and standard deviation will be equal to the average of population mean and the standard deviation of the population. See, the whole game of center limit theorem or sampling estimation is sample and this population. Okay, so both the statements are true over here. D is the answer. Both 1 and 2 are true. Such difficult questions are asked in exam. These are really difficult, and for that you need to join the classes. Paid classes. Okay. Among the below mentioned, which of the following is or are one of the key functions of the compliance department? Key functions of the compliance. Now, compliance department is an important department in module C also. Module C you have D is the main compliance part. Okay. So module D is mainly for compliance. Got it? But C also will give you the idea about because it's all loan. Module C is all about loans. So there you have to do the reporting. So there the compliance department comes. So which of the following are one of the key functions? Idea dissemination, information dissemination, parameter dissemination, and risk dissemination. Which of them is the key this function? The key function is, see, always remember, compliance has to do the information dissemination. Their main job role is information. They will have to distribute the information in the all of the departments, so that all are on the same page. That is very important. All of the departments should be on the same page. Got it? Information dissemination is the main role of any compliance department. Okay? Next one. Linear function z equals to ax plus by, where a and b are constants, which has to be optimized, is called as. So this linear function z equals to ax plus by. Now this has a and b are obviously constants. Now this has to be optimized. So optimized means what? Optimization. Optimization is required where? This is a LPP question, LPP. So this linear function is called as what? Objective function, constraint. Okay, constraint. Then optimization problem, or none of the above. So remember, in any LPP problem, linear programming, you have two things. LPP, you have two things. One is constraint equations. There are many constraints. Okay. And second one is constraint. Second one is objective functions. Okay. Objective function. So these are the two things always in any LPP. This function we call it as Z function. Z function is always an objective function. So this Z becomes objective. This has to be optimized. Now what do you mean by optimized? In optimization means, see, I'll draw a LPP, graphical solution of LPP. I'll show you simple graphical solution. Suppose if this is my feasible area, we call it feasible area. If this is my feasible area, then what have I to do? I have to move this z function from here to here to here, all the points. All the points I'll have to move this z function. And whenever I move this z function, and if I am asked in the question whether I have to maximize or minimize, if I am asked to maximize, then wherever I'll get the maximum answer, that will be my solution. If I have been told to minimize, wherever I am getting the minimum answer, that will be my optimum solution. So optimization means actually moving this z function. This z function, I'll draw it like this. This z function on here, then on here, and on here. All the 3 points you have to move this. And this is called as objective function. Okay? These are the constraints. You have to move your z function across all the constraints. Okay? Got it? So this is objective function. Which of the following method is applicable to any problem that can be formulated in terms of linear objective function subject to a set of linear constraints? So which method is useful to solve any of the LPP problem? This is related to LPP, linear programming, LPP. Okay? So which method is useful in all the any LPP problem? Firstly, for that you need to understand two methods. There are two methods in LPP. One is graphical, and second is simplex. Okay? So which method is best used for all? So kindly remember, simplex method can be used for any of the LPP, any. Simplex can be used for any of the LPP, but kindly remember one important point. It is very difficult. In your exam, you do not get a numerical on simplex. You will not get a numerical on simplex. No numerical. In your CAIIB exam, you do not get a numerical on simplex. Graphical is a bit easy. Just now I showed you one graph. So that is the graphical way. You always get the numericals on this, not on this. This is theory, you will be getting it in the exam. In exam, you will get the theory on this, not the numerical. Okay? So the answer for this is, which is the best method? Graphical, simplex, using R. This is not a method used at CIB level. And using open solver. These are all AI related and technology related. So move out. So the correct answer over here is simplex. Okay? Which of the following is the tendency for a single negative attribute to cause raters to mark everything on the low end of the scale? So which is this tendency for a single negative attribute to cause the raters, means the one who is giving the rating, to mark everything on the low end of the scale? Low end of the scale. Low end. Kindly note, low end of the scale. Now this question may be asked in your exam. I have seen this question once or twice. Okay? So it may be asked. You can't say immediately that it will be asked every time because it's not there in your book. Okay? But it can be asked because this effect is known as halo effect. Okay? Halo effect. This halo effect will cause the raters, okay, to give it on the low end. So low end is on the horn effect. Halo effect will give halo effect is not, halo effect is related to something else. It is horn effect. Horn effect will give the means the tendency for a single negative attribute to cause the raters to mark everything at the low end of the scale. It is called as horn effect. Okay? Next. Which of the following statements is or are correct with reference to kurtosis? So which of them is correct regarding kurtosis? Think of it, read. So read this, kurtosis. See, skewness and kurtosis. These are the important chapters, important topics in your ABM chapter number 3. Skewness and kurtosis. Okay? Measures of central tendencies. Very important, very difficult chapter. And skewness and kurtosis are really difficult. So which of the following statements is or are correct with reference to kurtosis? Kurtosis gives what? See, understand the logic of skewness and kurtosis. Skewness means if this is my central, see, if this is my center, okay, then my skewness will give how much deviated my curve is. See, ideally this curve should be like this, right? But if it is deviated like this, so it is away from the center. So this is called as skewness. Q. Okay. What is kurtosis? It gives you the length of the curve. Top. See, this is, or this way it is, or it is this way. There are three types of curves: mesokurtic, leptokurtic, and platokurtic. Okay. Lepto means top one. This last one is known as lepto. This is lepto. Leptokurtic, lepto. This is meso, and this is platokurtic. So these are the three curves. Okay, leptokurtic, mesokurtic, and platokurtic. So that's why I'm saying this topic is really difficult. There are various equations, there are various formulae for this. Follow the classes for the same. This is just a test. Okay, this is, you can see everyone get the test by just clicking on the link below. Okay, in the comment section, pin comment. So a normal curve which is symmetrical and bell shaped is known as mesokurtic. If a curve is peaked at the top, it is known as platykurtic, or plateau you can call it, platokurtic. If a curve is more flat than the normal curve, then it is known as leptokurtic. So which one of them is true? You want true one, right? Correct. So which one of them is correct? So think just now, see, compare this figure with the three options and then you'll get the answer. Compare it, everyone. Compare the figure with the given options. First one, normal curve is symmetric and bell-shaped, is known as mesokurtic. So first one is correct, because see this middle one which I have given, meso. Look at the meso. This is meso. So symmetric and bell-shaped. This is mesokurtic. That is correct. If the curve is peaked at the top, it is known as platokurtic. Is it so? No. Plateau is flat. Top one is lepto. So this is, second one is wrong. What about the third one? If the curve is more flat than the normal curve, so more flat than the meso curve, normal means meso, it is known as lepto. No, it's meso. So only correct answer over here is only one. These two are exactly interchanged. If the curve is peaked at the top, it is called as leptokurtic. If the curve is flatter, it is called as platokurtic. Got it? The difference? Using 95% confidence interval to estimate the true proportion of students who want to learn the foreign language if the mean is 25 and standard deviation is 4. See this, 95% confidence, and you want what? Who want to learn foreign language with mean is given as 25 and standard deviation is given as 4. 4 is the standard deviation, but for this number of students is required. Okay, number of students is required in this case. Got it? So, how do we find this? Yeah, this is the real problem. See this, the full problem, because if you want to find out the proportion, you need to know importantly you must know, the point over here is you must know the standard error. For that you must know the standard deviation. You must know this number of sample size. Okay, so sample size is equally required over here. Got it? So now let's solve it. See, first what you have to do is you have to find out the standard error. For finding the standard error, what you should do? What is the formula for standard error? See, standard error, this is a binomial problem because either the students want to learn or they don't want to learn. For binomial, the standard error formula equals to standard error, okay, equals to root of PQ upon N, PQ upon N. So that is equal to what? PQ upon N. Solve this. P is what? P is those who want to learn. So how many are there? 58 of the sample want to learn. 58 want to learn. So 0.58. See, out of 158, so take it 0.58 into. So if 58 want to learn, how many of them are there who don't want to learn? So out of 158, yes, so no's are 42. So it is 0.42. 0.42. The whole upon N. What is N? 100. Sample size. Say this. 100 students sample size. So solve this now. When you solve this, what will you get? Do it everyone. 0.58 into 0.42. Okay, 0.58 into 0.42 into 0.42 upon 100. So if you do this, I am getting this as 0.5 final figure. 0.5 I am getting it. Are you getting the same? Let me check it again because these are difficult problems. 58 into what? 0.42 divided by 100. So 0.002436. 0.002436 and square root of this. So square root of 0.002436. So that is equal to square root of 0.002436. So I am getting it 0.049. So roughly 0.05. That's what? Correct. So it's always required to cross check. So it is 0.05, not 0.5. 0.5. So this is my standard error. Now what do I want? I want 95% confidence. When I want 95% confidence, it means 2 standard error. This means 2 standard error. Okay, 2 standard error means what? 2 into 0.05. So 2 into 0.05 means 2 into 0.05. So that is equal to 5 to the 10. So 0.1. So this 2 standard error, I'll do addition and subtraction to the mean. So what is the mean? Mean is given as those who, see this, the true proportion want to learn foreign language with, if the mean is 25, this is 25 mean. So what will I do? 25, very difficult one, huh? Plus or minus 0.1. So there you will get the answer as 24.9 if I do the minus. And if I do the plus, then 25.1. So this becomes your answer. And see, this D is the option. 24.9 and 25.1. Difficult one. Okay. So now everyone, before going, kindly note, the new batches of CAIIB are starting on 23rd of Jan. Okay, this 23rd Jan, this new batch is starting. Officers Pro batch, kindly note, 2.0. Join this immediately. Detailed batch, all the numericals, objective questions, case studies, everything is covered. Don't miss this very important batch. Because concept is very important. In this you get all the concepts clarity, ebooks, mock test, live classes, everything is there. Plus we'll give you the handouts also. Remember the code for purchasing. The code is Y432. Y432. Okay, click on apply. Look at this. 82% discount you are getting plus 1% extra by downloading the app. Download it and then purchase. 83% you will be getting. Discount, huge. So join this batch. It's one more option I'll give you. Batch is there. One more option is join the Mahapack. See this, increment Mahapack. If you join CAIIB increment Mahapack, you'll get triple validity offer over here. What is triple validity offer? You buy for 5 months, you get it for 15 months. You buy for 9 months, you get it for 27 months. Huge it is. So join ASAP. In this you get 15 plus batches per subject. Okay. Plus you get physical question bank, physical formula bank, study planner directly delivered to your home, physical books. Plus ebooks are there, mock test, live test, full length mock test, same as that of your subject, of your main paper. So don't miss. Okay. And never forget the code. The code is same, Y432. Never forget this code. Okay. For getting these discounts, various validities. Okay. Bye.